Hi all, I'm K. Surya working as assistant professor in the Department of ECE at SNS College of Technology. So today we are going to discuss an important topic in our digital measurement systems called the digital frequency meter. The frequency meter is an electronic instrument used to measure the frequency of an electrical signal. Frequency simply means the number of cycles completed in 1 second and it is measured in hertz. In modern electronics and communication systems, accurate frequency measurement is very important because almost every electronic device works based on signals of different frequencies. So, a digital frequency meter is designed to measure frequency accurately and display the measured value directly in digital form. Unlike analog instruments which use pointer movement, digital frequency meters provide numerical output, making the reading easier and more accurate. These instruments can measure frequencies ranging from very low values to very high radio frequencies. So, in many systems, they can measure frequencies from 10 power 4 to 10 power 9 hertz. So, before designing any measuring instrument, engineers must understand the needs of the users. This idea comes from the concept of design thinking. So, in the empathy stage, engineers observe technicians, students, and users working in laboratories or industries. So, they study the difficulties faced while using the conventional instruments. Some users may struggle with manual range selection, unclear displays, or slow response time. So, by understanding these problems, engineers can create better instruments that are easy to use, portable, and more efficient. So, now let us understand why frequency measurement is important. So, in AC electrical systems, the frequency meter is used to monitor the power supply, frequency, and maintain system stability. In electronics and communication engineering, frequency meters are essential for signal analysis, radio frequency tuning, communication transmitters, and testing electronic circuits. During troubleshooting, technicians use frequency meters to detect faults and verify whether circuits are operating correctly. Therefore, frequency meters play a major role in laboratories, industries, and research centers. Modern digital frequency meters are designed with advanced electronic technology. So many instruments now include auto ranging capability. Auto ranging means the instrument automatically selects a suitable measurement range without any manual adjustment. This improves user convenience and reduces human error. Most digital frequency meters are also microcontroller based. So the use of microcontroller allows the programmable functions, faster processing, digital displays, and easy integration with the computer systems or data acquisition systems. Accuracy is one of the most important features of digital frequency meter. So to achieve accurate measurement, the instrument uses a crystal oscillator as a time base. So the crystal oscillators provide highly stable and precise timing signals. Since the counting operation depends on accurate timing, the use of crystal controlled time base improves the overall measurement reliability. The working principle of a digital frequency meter is based on the pulse counting. So the input sinusoidal signal is first converted into a square wave or pulse signal using signal conditioning circuits. So these pulses are then counted over a fixed period of time. So the total number of pulses counted within the interval gives the frequency value. So for example, if 1000 pulses are counted in 1 second, then the frequency of the signal is 1000 hertz. So this concept provides accurate measurement of the values with the high precision. So next stage is the define and ideate. So here the engineers clearly identify the problem statement. So the technicians may need a frequency meter that provides instant readings without complicated settings. So in the ideate stage, engineers generate solutions such as automatic range selection, wireless monitoring, voice guidance, and digital displays. So this process helps in developing smart and user-friendly digital instruments. So now let us see the block diagram and the working principle of digital frequency meter in detail. The first section is the input conditioning circuit. So the incoming signal may be sinusoidal or noisy. So this stage converts it into a clean pulse waveform. So the next section is the gate circuit. So the gate opens for a fixed interval controlled by a time-based circuit. So during this interval, pulses are allowed to pass into the counter. So the counter counts the number of pulses received. Finally, the display unit shows the counter value as the frequency measurement. So because the reading is displayed digitally, there is no parallax error and the measurement becomes more accurate and easy to understand. Frequency meters are generally this is classified into three types: moving ion frequency meter, electrodynamic frequency meter, and vibrating reed frequency meter. So the first is the moving ion frequency meter, which works using magnetic effects produced by the alternating current. So the second is the electrodynamic frequency meter, which operates based on the interaction between the magnetic fields produced by the fixed and the moving coils. And the next one is the uh, vibrating reed frequency meter, so which contains metal reeds tuned to different frequencies. So when the applied frequency matches the natural frequency of a reed, it vibrates strongly, indicating the frequency value. Although these analog instruments were used earlier, digital frequency meters are now preferred because of their high accuracy, compact size, and faster response. Now let us see the advantages of digital frequency meters. So they have good frequency response and high sensitivity. They provide accurate readings and are easy to operate. The production cost is comparatively low because of modern integrated circuits and digital electronics. Digital displays reduce reading errors and improve reliability. These instruments also support automatic operation and integration with modern electronic systems. However, digital frequency meters also have some limitations. In certain conditions, they may not measure the exact value because of noise or signal distortion. They also require electronic circuits and external power supply for operation. Despite these limitations, their advantages are much greater, making them highly useful in present day applications. So the digital frequency meter is an important electronic measuring instrument used to measure signal frequency accurately and efficiently. It works based on pulse counting and uses advanced digital techniques for precise measurement. So these instruments are widely used in the following applications like electrical systems, communication engineering, testing laboratories, industrial applications, uh, special motor speed measurements, electronic circuit testing and design in telecommunication systems, automotive applications in research and education, and so on. So with features like digital display, outer range microcontroller based design, and crystal controlled accuracy, digital frequency meters have become an essential part of modern electronic measurement systems. This is the mind map of whatever we have seen. So we have seen about the types of meters, we have seen about the key components, applications, and advantages and disadvantages. Thank you for watching this video.